Ever find yourself wondering how we go from a simple question to, well, a real solid answer? How do we actually know the things we think we know? The secret is research. But here's the thing. Research isn't just one single tool. Nope. It's more like a whole investigator's toolkit, packed with different gadgets for different mysteries. So for the next few minutes, let's open up that toolkit and see exactly what's inside.
I mean, that's the big one, isn't it? It's the question that drives everything, from figuring out the secrets of the universe to just understanding ourselves a little better. And that's all research really is. It's the method we've developed to turn that natural curiosity into knowledge we can actually trust.
At its core, it's all about being careful and systematic. It's about getting past our own assumptions or what our gut tells us. Instead, we gather evidence methodically, we analyze what it all means, and then we build a foundation of understanding that other people can actually test and build on.
Okay, so every single investigation has to start somewhere, and it starts with a clear purpose. Before a researcher does anything else, they have to ask the most important question of all. Why are we even doing this? And the answer to that why is what tells us which tool to grab from our kit first. Are we just exploring to learn something new, or are we trying to fix a specific problem?
And that question leads us to the first big division in our toolkit. On one side, we've got basic research. This is all about pure curiosity. It asks why, just for the sake of expanding what we know as a species. Then on the other side, you have applied research. This stuff is mission-driven. It asks how, because it's focused on solving an immediate, real-world problem.
So for basic research, just picture a biologist out in a field, totally fascinated by bees. They're spending hours and hours figuring out that little waggle dance they do. Now the goal isn't to make better honey or anything like that. The goal is just knowledge itself, to add a new, amazing piece to the puzzle of how the natural world works. That's basic research in a nutshell. Now let's flip that coin. Think about a team of scientists working around the clock to develop a new vaccine. They're using all that fundamental knowledge about how viruses work, knowledge that probably came from decades of basic research, but they're using it for a very specific, practical mission, to stop a disease from spreading. That's applied research. It's a direct response to a major problem.
So once we know our why, the next decision is all about the what. What kind of evidence, what kind of information are we actually going to collect to answer our question? This choice points us to the next layer of tools in our kit, and it really shapes the kind of answers we're going to get.
And this brings us to the two big worlds of data. First, you have quantitative data. Think numbers, stats, measurements, anything you can count. It's awesome for seeing big picture patterns. But then you have qualitative data. This is the world of words, of experiences, of observations. It gives you the depth, the context, the story behind the numbers.
So for example, a quantitative study might survey, say, 1,000 students about their study habits. What you get back is hard data. You get averages, percentages, and you can see trends. It gives you this incredible bird's-eye view of what's happening across a huge group of people.
But, numbers almost never tell the whole story. To really get the why, you need qualitative data. So you might sit down and do in-depth interviews with a few of those students. And that's when you hear something like this. This quote. It doesn't just add a little flavor, it gives you a massive insight into the feelings and the motivations that actually explain the numbers you saw earlier.
All right, we've got our why, our purpose. We've got our what, our data type. Now for the really hands-on part of the toolkit, the how. How do we actually go out and collect that data? This is where we pick a specific method, which is basically the engine that drives our whole investigation. And there are a bunch of ways to do this, but they all answer different questions. Descriptive research just paints a really detailed picture of what's going on. Observational research is about watching things as they naturally happen, without getting involved. But two of the most powerful, and honestly the two that get confused all the time, are correlational and experimental research. So let's zoom in on those two.
Correlational research is fantastic for spotting connections. For instance, a study might find a clear link. Students who say they sleep more also tend to have higher GPAs. You see a pattern, right? A relationship between two things. But this is the exact moment where we have to be super, super careful. Because when we see that connection, our brain immediately wants to jump to a conclusion. It seems so obvious. More sleep causes better grades. Case closed. But a good investigator knows to pause right here and ask a crucial question. Does this link really mean that one thing is causing the other?
And the answer 1,000 times over is no. This is maybe the most important rule in the entire investigator's handbook. Correlation does not equal causation. It just doesn't. Maybe there's a third thing going on. Like maybe students who have better time management skills both sleep more and get better grades. See? Correlation shows you that there's smoke, but it can't tell you what's causing the fire.
To prove that cause and effect relationship, you need a different tool altogether: experimental research. This is where you actually step in and change something. You create two groups that are as identical as possible, you give one group the thing you're testing, like a new drug, and you give the other group a placebo. If the group that got the real drug improves and the other one doesn't, now you've got some powerful evidence that the drug actually caused the improvement.
So we've got tools for our purpose, tools for our data, and tools for our method. But you know, the really big, messy, important questions in life, they rarely give up their secrets to just one tool. Sometimes, to get the full story, you have to combine them. And this brings us to the master tool in our kit.
And that master tool is called mixed methods research. It's a really smart approach that combines the best of both worlds. So a researcher might start by sending out a huge survey to thousands of people to get the hard numbers, to see the big patterns. Then, they'll follow up by doing in-depth, one-on-one interviews with a handful of those people to understand the stories and the reasons behind those numbers.
And when you put those two things together, you get this amazing, complete picture. The quantitative data gives you the what, the scale of the issue, and the qualitative data gives you the why, the human meaning behind it all. Together, they give you an answer that's way more powerful and insightful than either one could on its own.
And really, that's the big takeaway from all of this. Good research is never random. It's a deliberate choice. It's all about carefully picking the right purpose, the right kind of data, and the right method that perfectly fits the question you're trying to answer. It's about choosing the right tool for the job.
So there you have it, a quick tour of the Investigator's Toolkit. Now the next time you hear about a new study or see a statistic, you can think a little differently about how that knowledge came to be. Which leads me to one last question for you. Now that you have the toolkit, what's one question about the world that you would want to investigate first?